For this problem, we have to solve the limit as x approaches infinity of this expression. And to first see if we can just plug in this value to determine the limit, we run into a problem. Infinity isn't really itself a number, so you can't just go ahead and plug it in place of x. But we can still reason out what happens to this expression as x gets really large. So by that I mean, if you have 20 over x, and you know x is approaching infinity, it must be that 20 over x is getting closer and closer to 0. So once we know that this is true, we can go back to the limit and say, well, as x gets really big, 20 over x here and here both get very, very close to 0. In fact, that's where it should end up. So in the numerator, I'll put, well, this is going to be something like e to the 0 minus 1 over 0. So that's what the limit should be equal to. And I already see there's a problem. We're dividing by 0. I know you can't really do that. In the numerator, e to the 0 is the same thing as 1. So I'll put this is really 1 minus 1 over 0. And 1 minus 1 is 0. So what happens here is, as x gets really large, these two things go to 0, and it makes the fraction reduce to an indeterminate form. So you can't solve the limit this way because, well, this isn't a particular value, so this will not be the approach to take. Instead, we're going to use L'Hopital's rule by differentiating the numerator itself and dividing by what we get when we differentiate the denominator. We're going to take the limit of that expression. So for my next step, before I actually start taking derivatives, the expression 20 over x is not really written in a great way to take a derivative. So I'm going to rewrite it. I'm going to write 20 over x as 20 times x to the negative 1. So the exponent on this x is a 1. So if you want to bring this whole thing to the numerator here, you just make it negative 1. Same thing goes for what happens inside this exponent. Written this way, it'll be a little bit easier to take the derivative. So that's the next step. We're going to apply L'Hopital's rule. Starting with the numerator, okay, if you want to take the derivative of e to something, well, it is its own derivative to start with. It's e to that thing, but by the chain rule, you have to multiply by the derivative of this. So the negative comes down front, multiplies to the 20, and then we subtract 1 from the exponent. That is, you get negative 20 times x to the negative 2. And here, the derivative of 1 is 0, so that means I'm not going to write it. Now if we look at the denominator, okay, same idea. I can bring the 1 down front, the negative 1 down front, multiply it to the 20, copy down the x, and subtract 1 from the exponent. So within the denominator, I get negative 20 times x to the negative 2. And this is going to simplify really nice for us. I can completely cancel this with this. What I'm left with is the limit as x approaches infinity of, well, there's no fraction anymore because the denominator is 1. I'm going to write e to the 20 times x to the negative 1. So now if you want to evaluate the limit, I think we can go back to arguing like what we started with up here. And maybe I'll rewrite this back so it's a fraction so it's a little bit easier to think about. This is the limit as x approaches infinity of e to the 20 over x. As x goes to infinity, 20 over x goes to 0, so this limit should be equal to e to the 0. E to the 0 is the same thing as 1, and that's the final answer for this problem.